start the notes here. All right, so the section we're covering today, this is the last section from chapter 4. And this one basically is a summary of everything. So we're going to take everything we learned in chapter 4 and apply it now to actual questions, some real life questions. So we're going to need to figure out, are we using combinations? Are we doing permutations? Are there restrictions? How can we go about solving it? So here we've got Miss Sarah. Do you guys remember Miss Sarah? I don't know how long ago she was. She used to be the math teacher that's up where Miss Camille is right now. Might have been 2 or 3. Yeah, before Mr. Mana. Before, there's been many people in that room. Anyways, so she's got some favorite students. They're doing a group photograph. And what they're telling you is you've got 3 boys and 3 girls in that class. And the photographer wants the boys to be together, the girls to sit together, and then obviously Miss Sarah's going to be in a different spot. And we want to know how many ways can we arrange all of these people. It shouldn't be 6. It should be 3, 5, 8, 9.
So 8 combinations.
But there's some restrictions with this. So I need the boys to be together and the girls to be together.
Yeah.
So I can't just have them sitting however they want.
So 3 combination. What is it called?
Yeah, combination. Yeah.
9, and then I get after that, and then 5, and then combination, and then 9.
You're close. So let's deal with first. Okay. Let's just assume I can treat this as 3 objects. So I can say, here's Miss Sarah. Actually, I'm going to put this above. So let's say this is Miss Sarah. Then I'm going to say next we'll put the boys, and then next we'll put the girls. I can switch these around, but for now, let's say these are as a single unit. So how many ways can I rearrange Miss Sarah?
Sorry?
How many different ways could I arrange Miss Sarah so that she's in different positions in that one spot?
There's only one Miss
There's only one
Sarah.
Miss Sarah, so it's just one. For the boys, I've got 3 of them. And does the order matter in this case?
No.
Yeah. If you're trying to order them from, say, tall to short or something, it matters whether you've got, I'm not going to use specific names, but if you have someone who's tall and then short and then tall, it normally doesn't make for the greatest of picture. So order here does matter. So for the boys, I've got 3, so it's going to be 3. The order matters, so it's P, and I want to use all 3. How about for the girls? What am I doing for the girls in this case?
You're going to P, and then 5, right? 5.
So it's going to be 5. We're going to do P because, again, the order matters. 5.
Wait, Miss Sarah, can I ask a question?
Yes, you can.
What does P stand for?
Permutation.
And why don't we use it? When?
So permutation is when it matters the order that you put the objects. Combination is when it doesn't matter.
What?
Combination is when it does not matter. So for instance, let's say, so let's take these 4 items. So suppose I want to write a word on the board and I'm going to pick different colors. So when I rearrange these, it changes the order that I write the colors. So the order would matter as to which one of these I pick first and which second. If I just said, I want to pick 2 of these to bring to school, it doesn't matter if I pick the black first and then the blue, or the blue first and then the black. Both of them are going to come with me. So if I'm just picking to put them in some sort of other group, combination. It doesn't matter which order I pick these. Whereas if there's a situation where black first and then blue makes a difference, permutation. So that's the difference between those 2. So the main thing we want to look at for these kind of questions is, does the order matter? That's initially going to tell you, am I dealing with permutation or combination? So I've rearranged these, or I've looked at the ways I could set this up if Miss Sarah's first, and then the boys, and then the girls. But I can also rearrange these. Right? I could put the girls first, and then Miss Sarah, and then the boys. I could put the boys first, and then the girls, and then Miss Sarah. So I can also, if I'm looking at this whole thing, I can treat all three of these as single units. And I can say there's 3 items again, and I want to choose all 3. Now we're just looking at the sections. So that would be like in this class if we said that Mr. Cream and I are going to be the teachers, we need to be together, then we need to put the boys together, and then the girls together. And we can rearrange us in a bunch of different ways. So I can look at how I rearrange the girls within just the girls, or I can look at how all 3 of these groups are switched amongst each other. Can you kind of see where that's coming from? Okay. Let me see. How could I explain this? I'll use these pens and pencils again. So suppose I want to rearrange these items in my hands into a bunch of different orders. But I tell you, the pencils need to be together, the whiteboard markers need to be together, and the pens need to be together. So I need to look at, okay, how many ways could I rearrange the pencils? Well, it could either be this way, or I switch them in there this way. So I can look at just the pencils. Then I can look at just the markers. Okay, how many ways could I rearrange these markers? So it could be like this, I could switch it like this, I could switch it like this. There's 6 different ways I could do that. Then I look at how many ways could I arrange these pens. There's just 2. But I'm not just arranging within each of these like I did just in here. I need to also look at how could I arrange the whole thing. So I could put pencils, then markers, then pens. Or I could switch it and go markers, pencils, pens. I could switch it like this. So I could also switch the total arrangements, the girls, boys, and the teacher. Does that kind of help you visualize it a little bit more? So I could rearrange it like this, and then not only like this, I can switch within each of these groups. Or I could put it in this combination, and then switch the order of whatever's in here, but these ones have to be together. So it's a matter of, I can switch it within each category, and I can switch it each category in and of itself.
So I have to look at that you read under all boxes?
Yeah, to say I can rearrange the girls, boys, and the teacher. So the total number of ways is I'm just multiplying all 3 of these together. So I'm going to just go 1 times 3p3 times 5p5. That'll give me the total number of ways I can multiply these together. And then times again 3p3. Because that's just the number of ways I could do all this. Technically, it's like we're doing these number of ways times the total ways I can switch those categories. So this is something you should be able to put into your calculator, which will give you 4,320. And I just want to double check to make sure my number's correct with this. You got it? Okay, perfect. Good. So this is one of those situations where not only do I need to deal with the fact that, okay, P, so in this case the order matters. So because the order matters, therefore we need to use NPR. We need to use the permutation because the order matters. So this is kind of something that you'll need to do at the beginning of each question and just see, am I using P? Am I using C? Any last questions on this before we move on to the next one? And you'll see this process again. All right, so now we're coming back to our deck of cards. So if we're looking at 5-card hands. So if you've ever played any games where you're given a hand of cards, does the order matter? What order you get the cards in? No, it doesn't matter, because if you get the ace of hearts first or if you get it last, it's still part of your hand. So in this case, the order does not matter. So if the order does not matter, am I using the P or am I using the C? C, good. So because of this, we're using NCR. So I want how many different 5-card hands? And we're using NCR. So just a reminder with this, the N is the total number of items we're picking from, and the R is how many I want. How many that you're wanting. So in this case, I've got 52 cards total. So I'm picking from 52 cards, and I want a 5-card hand. So there's 52, I want 5 of them. There's 4 suits, but I want a 5-card hand. I know, it's a lot of different numbers that are in there. Yep. 2, 5, 9. Perfect, thank you. So there is a lot of hands that you could get. So any of you who like to play card games or want to, I know you're not supposed to be betting, but if you're playing a friendly game of poker that you're not actually placing bets, this is how many different card hands you could get. And then we're going to look at any restrictions that we've got. So this is just the total number of ways you could have. So now let's make a little restriction on this. So how many 5-card hands if you're going to consist of all hearts?
5, C, 13.
Other way around. You were very close.
13,
yeah. So why did you pick 13?
Because all hearts that each has 13.
Yeah. So if I'm looking at all hearts, I'm only picking from the 13 hearts. And I want 5 of them. So this 13 comes from the number of hearts that there are. 1, 2, 8, 7, yeah. So a lot less hands that involve 5 hearts.
But why does the 13 come first? Isn't it 5, like counting with 5 cards, then 5 goes first, and then all hearts go just 13 after?
So the bigger number should always come first.
Oh.
Yeah, just remember the bigger number should come first. If you did it the other way, it'd give you an error. Because then you're saying, from 5 cards, I want 13 of them. And you can't pick 13 cards from 5. Let's try another one here. So how many 5-card hands that can be formed with all face cards? So again, just a reminder what a face card is. These are the cards that will have a face on it normally. So the kings, queens, jacks.
So 4 each.
So there's going to be 4 of each of those, so there's 12 total. There's going to be king, queen, jack of spades, king, queen, jack of hearts.
So 12 C, 5.
Yep. So there's 12 total I'm picking from. I want 5 of them. Plug that in. So you see how we're just playing with the restrictions to get the numbers for this. So the math component of it's not too hard. It's trying to figure out what are the restrictions? What can I use? What can I not use? So here's probably the most complicated one, but it's not going to be too hard. So now we want a 5-card hand that has 3 hearts and 2 spades. So what you're going to do for this is first let's figure out how many ways can I get 3 hearts? Well, how many hearts are there total?
13.
There's 13. And how many do I want?
3.
3. So this is the number of ways I could get 3 hearts. Times, now I want to do the same thing for the 2 spades. Good, yeah, so 13 spades total, and I want 2 of them. So you can see we're still using the same concept. If I'm doing this many of this one, this many of this one, you're just going to multiply those 2 things together. Yeah, 22 and 308, and when you multiply those things together, you get 22,308. Good. Right, not too bad. And again, for all of these, because it's still dealing with 5-card hands, we still use combination because the order does not matter. Doesn't matter what order you put those. Okay. Let's flip over to the next one. Okay, the last one wasn't too hard. These are the ones that are going to be the heart of the hard questions. When you've got stuff where it says at least or at most. So if we are told that we want now a 5-card hand, and I want at least 3 hearts, what does it mean if I say at least 3 hearts? Yeah, it could be more. So I could have 3 hearts, I could have 4 hearts, or I could have 5 hearts. So what I need to do is I need to calculate the number of each of those cases. So I've got 3 cases. So the first case is I've got 3 hearts and 2 non-hearts, I'll just call them. Like anything that's not a heart. So it could be a spade, a diamond, or a club. Because I want a 5-card hand. If 3 of them are hearts, that means I've got 2 left that are not hearts. So that's one case. The second case, I could, yeah, 4 and 1, good.
5 and 0.
Perfect. So now, even though I've got 3 different cases, how I go about solving each case is just like the question before. So I look at this and say, okay, I want 3 hearts. How many hearts total are there to pick from? 13. Order doesn't matter. I want 3. Times, now I need to look at non-hearts. So how many cards are there that are not hearts? So I've got all the spades, which is 13 of them. I've got all the clubs, and I've got all the diamonds. 39. So what I'm left with is I have 39 cards that are not hearts. I want 2. Yeah. So then I do the same for the next one. There's 13 hearts total. I want 4. Times 39C1. Good. And we're going to do it again for the last one. So 13C5 times 39C0. 39C0, this is just going to give you 1. But just to show you the pattern for this, I put it in. Yep. So this gives you the number for case 1, the number for case 2, the number for case 3. You can put it in and get some number for each. Once you've figured out what each of these cases are, to get the total, I just add these. So add each case to get the total. So 13C3 times 39C2 plus this will get you your total. And that's just putting in your calculator. I'm not going to put it up on the board here. It's 241,098. Yeah. So you do this plus this plus this. Yeah.
So 39C3 times 39 blah blah blah, and then
Brackets.
Plus?
Yep.
Okay.
Yep. So you can give that a try once I'm done with the notes, and give that a go. I am going to skip the last one. It's the same thing. At most just means you can only have one black card. So it's either one black card or no black cards. But I'm not going to show you that because it's essentially the same as what we just did. I wanted to get to this box to give you more chance to do the practice problems. So this box at the end here is a nice summary of everything just to help you remember, okay, how do you go about solving a problem? And if you follow what's happening here, you'll be good. So when you're solving counting problems, first you need to figure out if order plays a role. Meaning, does the order matter? Does the order not matter? That will first determine if it's a permutation or a combination. Yeah, permutation. So once you figured that, here's a few more strategies. So first, look for conditions. What do you think I mean by conditions? That's what the order. Condition is something different. So condition would be something like you have to have all red cards, or you need only the face cards, or you need 3 hearts, 2 spades. Yeah. So as opposed to just saying, I need how many 5-card hands are there? There's no condition for that. It's just a general solve it. Condition is you need something specific. So if there's repetition of R, oh yeah. So I'll write this in and then I'll explain it. So dividing by R factorial. So this is the case where, do you remember when we figured out the number of combinations with letters? Was that with you or with the other group? Where I gave you stuff like, you've got these letters.
Oh, yeah, that'd be
Yeah, so then if you want the number of ways of this, you've got 5 factorial on the top, divided by 2 factorial, 3 factorial. So this is the condition it's talking about. So if you have repeats, do something like this. And this is a nice convenient trick, actually. So if you've got multiple tasks, there's connected by the word and, then you're going to multiply. If you've got multiple things that are connected by the word or, the fundamental counting principle does not apply, and so we're going to add. So what I mean by something like this is, look at our cases here. I want this case, or this case, or this case. So because it was this, or this, I added them. Whereas here I said I wanted 3 hearts and 2 non-hearts. Because they're connected by an and, I times. So if in the question you see an and, multiply. If it says or, you're going to add. This makes a huge situation. And that's usually when we did something that involves several cases. So as the above example, if you've got this situation, this situation, this situation, you're typically going to see the and the or. So that's just a little summary to help you go through the questions and to kind of help you remember as you're going through this. So as you go through practice problems, because it's all word problems, so it's tough to know where to start, go through these different points and that'll help you with your progression through that. Any last questions on this? Or is that pretty good? Perfect.